So our next speaker is Tiago Alves from Allbesmart, which is a company here in Portugal that is well known for the OAI box, which is, you could say, ready-to-go setups for OpenAirInterface, and there's a particular interest also in AI run and 6G, and following that he will now present the OAI box AI run open source AI native test, OAI native 6G test network.
Thank you, Robert.
So, just for you.
Okay.
If you need, you can speak like this.
Okay, I don't think so. So, my name is Tiago, for those who don't know me.
Please use that mic because we will...
Okay. So, my name is Tiago, as I was saying, and I'm here to present OAI Box. First of all, I would like to thank you for the invitation to organize this nice workshop here in Portugal. It's important to us as well, as members of the OAI Alliance. So, first I would just like to give an overview of our company. So, Allbesmart has been established in 2015 in Portugal, in a small city 300 kilometers from here, to be almost exact. We have been for some years associated members of the OpenAir Software Alliance, and we have been contributing to the code since at least 2018. So our team contributes daily with development, testing, debugging, and even support. So we have created the OAI Box as an open source research-oriented test bed for experimenters to use to tackle their open run and AI run experiments without any sort of closed source. So everything is kept as open source in our boxes, and as you will see in a few slides, every contribution comes back again to the community that helped also build our product. So what is the OAI box? As I have been saying, it is a complete end-to-end 5G and 6G network in the box, with a 5G core, radio access network, and even DUE. Everything ready to run. We use OpenAirInterface in all of these components on the network, including even the near real-time RIC and XApps. Our customers usually are research labs, either universities or industry, that already have SDRs, mainly USRPs from NI, and some even have commercial off-the-shelf radio unit that we support. So these types of customers can then acquire an OAI box, in this case the Max, and bring a new life into these equipments. Sometimes they are just collecting dust on shelves. Our product is flexible enough, even on the form factor. We have such workstation PCs that are water-cooled, quite silent. Researchers can share the lab bench with them, and for those who require heavier AI run workloads, we also provide server formats. There are quite a lot of synergies between OAI Box and OAI, and I think this is not always obvious to everyone. So OAI Box uses OAI as its foundation, which means that, as I said, the components come from OpenAirInterface. OAI Box is the way of making the adoption easier. It's a lower barrier to entry for teams who don't have the time or resources in short-term projects to build the entire end-to-end network. I will explain, I will show you one of the common issues, some of the common issues that we find that are usually attributed to OAI, but in fact are just related with the testbed. So we fill the end-to-end gaps. OAI is the only solution that currently has the open source UE, and this is quite important when tackling AI run use cases or ISAC scenarios. And our support team is always there to complement what is the support that the community already provides. So at this very moment, we have handled 700 plus support tickets through our platforms without, of course, putting this extra effort into the OAI community. As I said, every contribution that we do, either fixes or new developments, goes back upstream to the OAI source repos. So looking into the common issues that we see, to me this is a funny slide because sometimes we receive, these are actual titles, by the way, of support tickets that we have opened. So an issue with starting the Gnode B, and then our support team has a troubleshooting session and finds out that the customer just switched around 2 cables on the USRP, resulting in an error, preventing the Gnode B to start. This is a very common one. Then another ticket, I am unable to start the CU. And then after digging, going back and forth, a few emails, we found out that the customer had moved premises, moved the entire test bed to a new IP network and forgot to adjust F1 IPs, so typical. The UE does not attach to the OAI box max. After requesting some pictures, because we also could not understand what is happening, some pigtails were disconnected on the Quectel board. And the one that takes the cake, the most common, is the Quectel commercial off-the-shelf UE fails to register with OAI. So this was happening on a weekly basis until there was some developments on the radio access network and core network even to support the default DNNs that the Quectel supports. So seemingly, the thing that customers like the most to do is to remove the SIM card from the Quectel as soon as they get it. I don't know why, but it's something that happens. A synergy that we don't explore often is the reach. So every OAI user is a potential OAI box customer, but every OAI box customer is a known de facto OAI user now. We have deployed 204 OAI boxes across the world, arranged in 157 test beds on more than 100 customers. This is just a short summary of our product line, at least the default configurations. We can start by the 5G Lab kit, which pairs with the OAI box 5G Lab manual for a ready-to-teach curriculum throughout the full semester, with some exercises that the students can learn 5G and 6G from. Then our most deployed unit, Florian asked me this question this morning, it's the OAI box Max, which is capable of FR1, FR2, and FR3, depending on the front end that we connect to it. Some customers looked into the Max and then asked us to experiment with the mid-haul and front-haul connection, making advantage of the Open RAN architecture. So for those, we have split the Gnode B into 2 boxes. Therefore, they can experiment by impairing the mid-haul or even do some experiments in the front-haul. Moving on to the AI run side of things, we have the DGX Spark as a starter. Then we have the AI run OAI box, which it's a powerful CPU combined with an RTX 6000 Pro GPU. And then we also support the GH200 architecture. The facilitating tool that our customers usually use, it's called the OAI box dashboard. And it provides a one-panel, full end-to-end overview of the core network, Gnode B, near real-time RIC. You can see the entire status of the network. You can even see telemetry, in this case, from a GPU. This is running on an NVIDIA Spark. When someone needs to configure the Gnode B, the process is quite simple. It's configure, press start, and repeat whenever changes are required. If the user wants to see the live KPIs and radio metrics, they have a dedicated view per UE that they can see as well. Our company is a member now of the AI Run Alliance, which defined 3 verticals for AI use cases. So AI and Run, AI on Run, and AI for Run. So we try to design our test beds and our facilitating tools to tackle each one of these verticals, and we have defined some reference use cases that our customers can use to then build their research upon. So the first case is the AI end run. So here you have one GPU and two workloads. This is the classical use phi on one of the MIG partitions of the GPU with Arial, and then you run another AI workload alongside the Arial phi. So what we did here was we used the spare capacity of the GPU to run a YOLO inference algorithm on a live feed classifying cars going up and down the street. So this is more so to prove that it's easy and show our customers how it is done to do the MIG partitionings and assign one to one aspect and one to the other. On the AI on-run vertical, we have experimented quite heavily in these past few days with the Isaac use cases. So here the signals are sensors. We are using signals and sensors, and we have built this intrusion detection Isaac use case based on 5G and R reference signals. So this case was using SRS signals. So it's using today's existing 5G waveforms, just exposed from OAI. And on the coffee break area, you will be able to see that there is a demo that's outside, and that demo is there showing precisely something similar to this. So on that demo, we picked up on this information and then built the range Doppler map. And I would like to invite you to go there on the coffee breaks and during the demo session. The last vertical, the AI for run, we have been engaged in a project where we are doing dynamic spectrum sharing with proactive PRB blanking. So here, there was an incumbent that our network was sharing spectrum with, and this the spectrum was being sensed so that the PRBs can be blanked. So applying AI to this makes it predictable. Since the incumbent activity was periodic and therefore learnable, an AI model could forecast and blank the PRBs ahead of time. Next up on our roadmap, something we would like to experiment with would be a neural receiver for this vertical as well. Besides these three verticals, we are also using NVIDIA GPUs, in this case, to do the digital twin. So our work was inspired by the work shown previously by Sebastian. I think he's on the audience. And we have built the OAI box digital twin, which is on the right of this image. And we are using the GPU to do ray tracing and using Xion RT. And then this visualization is done at the OAI box dashboard. So we have integrated both worlds. We make it easier for the users to build their own 3D scenes. And with even known tools like Mitsub and defining the UE routes with Sumo. This is something that you can see also in the live session demo. Not this test bed as it is here in the picture, but with the 3D model from the downtown of Gaia in this case. And here, where you see the blue dot, which is representing the G-Node B, it is actually the place where we are going to have the gala dinner later today. So you are more than welcome to check this out also at the demo section. And the test bed will include one of the Sparks as the G-Node B and the other Spark as the OAI UE. So everything from the network standpoint, there is running on CPU, and then we are using the GPU for the ray tracing. It is also possible to combine all of these worlds using our solution and use the digital twin for Isaac proof of concepts. So sometimes it's hard to validate Isaac scenarios because it's hard to reproduce what's happening in the real time. So once you calibrate one algorithm, it might not work in other circumstances. So here, for example, we have built a 3D scene with our digital twin, in which we have the Gnode B in red, and we have the UI in blue. So it's like a monostatic header approach. And then, completely disconnected from the network, you have the drone, which also reflects some energy back to the UI. So this is just a proof of concept. We think researchers can leverage these types of digital twins to then validate their ISAC algorithms for other applications. So from my part, I thank you once again, and I leave the floor open to questions if there are any. Thank you.
Hi, my name is Muha. I'm from German Aerospace Center. I just wanted to have one question about OAI box. Do you have any plans in the future works to extend the functionality into non-terrestrial networks? Because we are quite interested in that realm. Thank you.
Yes, we do. NTN is something that we are considering under curtains, but it's something that we want to have built at some point. Maybe not on the short-term future, but it's something that we will have, yes.
Thanks for this presentation. I'm Joe Harry from Eurocom. Just a brief question. So I like this Shiona RT 3D building with ray tracing, but the visualization itself, what was the software you used?
So we built our own visualization stack. So we extract the traces from the Shiona RT. We put it in a web page format for you to be able to see. So we use, the stack is HTML, then 3JS. I don't know if you are aware of 3JS, which is a 3D library for the web browser. Yeah.
You can visualize it in 3D.
Yeah. Okay. You can see it at the live demo.
Thank you.
Thank you.
Okay, thanks a lot, Tiago.
Thank you.